F912. Determine the center of mass of the homogeneous solid block. For this solid block, I'm going to break it up into three pieces. There is this right triangular prism right here, this right triangular prism right here, and this rectangular prism right here. And I'm going to call these items 1, 2, and 3. For a rectangular prism, the centroid is easy to find. It's always halfway. Halfway in this direction, halfway in this direction, halfway in this direction. For a triangular prism, we could find the centroid of the prism itself through integration. But for a right triangle, we can use the trick that the centroid of a right triangle is 1/3 of the distance from the corner point. So 1/3 of the distance this way is the x component, and 1/3 of the distance this way is the z component. So using this, object 1 has a volume of, and this is the volume of a triangular prism, 1/2 from the triangle times the 3 dimensions. So times this length, which is 1.5 meters in the x, 0.5 meters in the y, and 1.8 meters in the z, for a total volume of 0.675 cubic meters. Triangular prism number 2, we can see, has the same dimensions. It's 0.5 by 1.5 by 1.8, so volume 2 is also 0.675 cubic meters. And for the rectangular prism, and this is something we need to be careful about, this dimension is not 2 meters, rather 2.5 meters, something that they might be trying to trick you with. So the volume of this rectangular prism is 0.5 meters times 1.8 meters times 2.5 meters. To find the centroids of each of these individual pieces, for this piece right here, the x component is this 0.5 meters that it's away from the YZ plane, plus 1/3 of this distance, because this point is 0.5 meters in the x direction, and we are 1/3 of this plus 1/3 of this length. That length is 1.5 meters, so plus 0.5. So it's 1 meter in the x direction. In the y direction, it's just half of this, so 0.25 meters. And in the z direction, it's 1/3 of this, because we're going up from the right angle, so 0.6 meters in the z direction. For this triangle, the x component is, the x is now the width, it's a 1/2 meter wide, so x component is 0.25 meters. The y component is 2.5, that's this distance, plus 1/3 of this length, so 2.5 plus 1/3 of 1.5, or 3 meters in the y direction. And in the z direction, it is also 0.6. Finally, for the rectangular prism, the centroid is halfway in each case. So in the x direction, it's 0.5 meters wide, so 0.25 meters. In the y direction, it is, again, remember, 2 plus 0.5, so 1/2 of 2.5, or 1.125 meters in the y, and 1/2 of this 1.8 meters in the z, so 0.9 meters in the z. To find the centroid of the figure as a whole, we take sum of xivi divided by sum of vi. So sum of xivi, I've done this component by component. So these are the I components. This is 1 meter times 0.675 meters. This is 0.25 meters times 0.675 cubic meters. And this is 0.25 meters times 2.25 cubic meters. Same thing with y, and same thing with z. And we get that the total quantity, the weighted location, is 1.4054 fourth meters I plus 4.724 fourth meters J plus 2.835 fourth meters K. The sum of the volumes is just the three volumes that we calculated added together, or 4.6 cubic meters. And so the location of the centroid is this weighted volume vector here, divided by the volume, and we divided component-wise, so 1.405 fourth meters I hat divided by 4.6 cubic meters is 0.305 meters I hat. So this is the x component of the centroid, this is the y component of the centroid, and this is the z component of the centroid. Now, one thing that's kind of interesting about this, if you think about this position vector, that is empty space. That is about, well, it's in front of this face. So there doesn't actually have to be a part of the object located at the centroid.